Unit number 4. Let us begin with what is software requirement analysis. Software requirement analysis is a process of collecting, understanding, modeling and documenting the software requirements which are essential to develop high-quality software. Mostly software engineer is responsible for the task of software requirement analysis, but in case of complex systems, this task is performed by the specialist commonly referred to as system analyst. It is the job of the system analyst to extract the exact requirements from the customer and specify them in a manner in which these requirements can be translated into software design. Software requirement analysis is the first step toward quality assurance. All the parameters of quality with respect to particular software should be clearly identified and specified at this stage. If software is being developed without clearly establishing the requirement, more often than not, the developed software will be solving wrong problem and it would be a waste of time, money and efforts. Let us focus on how this complex task requirement analysis is performed. System analyst begins with identifying externally observable data, functional and behavioral requirements. Data objects are either produced or consumed by the system. Example of data is employee record and salary slip. Functionality refers to software's ability to process or transform data. Maintaining customer record is an example of software functionality. Software behavior implies how it works under certain conditions, in other words, how software reacts to certain input or action or command. Example of software behavior is that when an employee data is being updated, no one else can access that data during updation. The second task of the system analyst is to create data model, functional model and behavioral model. Models are abstraction of real situation and are used to make complex things understandable. For the same reason, models are created at requirement analysis phase so that requirements could be easily understood. Of system analyst is to specify the requirement. The software designer uses the requirement specification to develop the design. The specification document serves as a basis to validate and assess the quality of the software once it is developed. Detailed discussion of this topic will come later in this unit. Let us go more into details of requirement analysis. Logically, software requirement analysis can be divided into 5 major areas of effort, all being equally important. These areas are: Number 1, problem recognition. Number 2, evaluation and synthesis. Number 3, modeling. Number 4, specification. Number 5, review. Let's look at each area one by one, starting from problem recognition. Gather the software requirements from the customer. Software requirement elicitation is the difficult part of the requirement engineering phase. A lot of communication between customer and system analyst is required. Opportunities of misunderstanding and misinterpreting are many. It is difficult to start the communication lines with the customer. However, there are a number of techniques to gather software requirement. In this unit, we will study 3 techniques of requirement elicitation. Number 1, meeting and interviewing. Number 2, facilitated application specification techniques. Number 3, quality function deployment. Thus, some broad guidelines for analysis of requirements. The first guideline states that the environment in which software will be deployed and used must be well represented and understood. The second guideline is that the functionality of the desired software must be defined. The third guideline is the behavioral aspect of the software as a consequence of the external events must be clearly represented. The fourth guideline is that the information, functional and behavioral models must be partitioned in a manner that they show the layers or hierarchy of the desired system. The fifth and last guideline states that the analysis process should begin with essential information and gradually move towards implementation details. Students, prototyping is another technique for requirement gathering. Remember, prototyping does not make meeting and interviewing, FAST and QFD techniques redundant or unnecessary. Rather, it supplements those techniques. We have studied prototyping in the unit number 2, that was from the perspective of process model, but here we will see a specialized application of the prototyping process model as a tool which helps both customer and development team reach common understanding of the requirements of the desired software. The prototyping approach almost always assumes that the model will be a working model, that is, a collection of computer programs that will simulate some or all of the functions that the user wants. But since those computer programs are intended just as a model, there is also an assumption that when the modeling is finished, the programs will be thrown away and replaced with real programs. Good candidates for a prototyping approach are projects that have the following characteristics. The user is unable or unwilling to examine abstract paper models like data flow diagrams. The user is unable or unwilling to articulate or pre-specify his or her requirements. The system is intended to be online with full-screen terminal activities. Almost all prototyping software tools are oriented toward the online, database-driven, terminal-oriented approach. The system does not require specification of large amounts of algorithmic detail. Good candidates tend to be the systems in which the user is more concerned about the format and layout of the data entry and output screens and error messages than about the underlying computations performed by the system. The prototyping approach certainly has merit in a number of situations. In some cases, the project manager may want to use the prototyping approach as an alternative to the structured analysis approach. In other cases, she or he may wish to use it in conjunction with the development of paper models such as data flow diagrams. Keep in mind the following points. Number 1. The prototyping life cycle involves the development of a working model that is then thrown away and replaced by a production system. There is a significant danger that either the user or the development team may try to turn the prototype itself into a production system. This usually turns out to be a disaster because the prototype cannot handle large volumes of transactions efficiently, and because it lacks such operational details as error recovery, audit trails, backup restart facilities, user documentation, and conversion procedures. Number 2. If the prototype is indeed thrown away and replaced by the production system, there is a real danger that the project may finish without having a permanent record of user requirements. This is likely to make maintenance increasingly difficult. Dear students, quality of software, among other things, depends on how requirements are specified. Complete, correct, and consistent requirement specification will ensure that right product is being developed and vice versa. Dear students, let us study now some basic software requirement specification principles. Requirements, no matter how specified, are viewed as representation process. Well-represented requirements will lead to successful implementation of software. Now we discuss software specification guidelines. Number 1. Functionality and implementation should be separated. At the requirement analysis stage, the focus ought to be identification of what is required. Thinking about how it is going to be accomplished at this stage is premature. It will only create confusion and hamper the quality of requirement analysis and specification. Number 2. Desired behavior of a system should be represented by appropriate model. The model should encompass data and functional responses of a system to various inputs. This exercise will increase the understanding of the working of the system. Basically, it will identify, given certain input, how system will respond. Number 3. The domain in which software will operate should be specified. The interaction among domain component and software should be clearly specified. This means the task software is supposed to perform should be clearly understood. Suppose software uses a database which is located on an independent data server and data server crashes, then this failure should not be attributed to the particular software. Number 4. Mostly software is part of a large complex system consisting of hardware, software, people and data. How change in any one of these will affect the overall system needs to be identified during specification. Number 5. Create a cognitive model rather than design or implementation model. The cognitive model describes the system as perceived by the user community. Requirement specification must be mutually approved by the software development firm and the customer. Cognitive model is easy to understand for the customer, and communication between customer and system analyst can be easily achieved. Our last topic is specification review. The specification review is conducted by both the software developer and the customer. Once it is approved, the specification becomes a contract for software development. During the review, changes to the specification may be recommended and adopted. Dear students, this is the end of unit number 4.